Good morning, good evening, good afternoon. I am Michelle DiPalma, Red Hat Principal Solutions Architect with the Data Services team, and this is the Data Services Office Hour. I have the pleasure of welcoming Mr. Kyle Bader today. Hello, Kyle. How are you?
Hello, Michelle. I'm Bader. Work out of our hybrid platform business unit here at Red Hat. I'm Data Foundation Architect, so coverage of our technologies like OpenShift Foundation and Red Hat Storage. But I've been working with the Red Hat at OpenShift Data Science team for a long time now. So
yeah,
I would on and have fun during the happiest hour.
That's right. So talk to me about what you want to present today and what we're going to dive into.
Yeah. So let me go ahead. I can bring something up. While doing that, I want to talk a little bit about Datablade Security. So if you're interested in using Red Hat OpenShift Data Science, the two platforms that it's available in are OpenShift by way of OpenShift Dedicated and Red Hat Open Service in Amazon. If we accidentally use the shorthand and acronym ROSA or OSD, don't fault me because we use it a lot. But I'll try to use the full formal name so there's no confusion.
Hard to remember to do it though. So just so you know, I am getting a little bit of feedback. I'm hearing a little bit of an echo right now, but you're talking nice and slowly, so I think it's manageable. Just so you know, I don't know if you hear it, but I hear it a little bit. Just wanted to let our viewers know. But go ahead. So you're talking at a good clip, so that's good.
All right.
Here we go.
So I'm going to go ahead and share.
Okay, your screen is presenting. Go ahead.
Okay, good. So yeah, Datablade Security. I wanted to go over kind of the CR and options that are available to you if you're kind of setting up a data lake in Amazon S3 or some sort of S3 equivalent, and kind of on top of the security capabilities of Amazon S3 using something like Starburst Data, which is one of our initial partners out of with Red Hat Data Science. They offer like a massively parallel processing engine based on upstream Trino, which originally was kind of goes back to the Presto project. So the Presto project originally started, and there was two flavors of it. Whatever is now Trino. The other one is Presto, which is a really great tool data lake. It's used by internally by the Amazon Athena service, and there's a lot of people using upstream. You can get it by way of EMR. If you're deploying EMR cluster, it's a pretty handy query engine. So it all kind of starts around authentication. It's almost a confusing number of different ways that you can do authentication and access control in Amazon S3, which is perhaps surprising given that S3 is the oldest service in Amazon Web Services. I think it originally started in what was it, 2006 or something? Wow, so that was like over a decade ago. That's amazing. It's hard to believe it's been that long. So kind of the initial thing that was available was just static credentials, and a lot of people still have static credentials for a lot of things. So static credentials is you get a set which includes an Amazon access key and an Amazon secret key, and then that secret key or the combination of those two things used to sign each request, each HTTP request that's sent to the object storage endpoint. That's all fine and well and works. There's a number of tools that support using static credentials. So whether you're writing something in Photo, just from a notebook, or if you're using something like the S3 file system client that comes by Hadoop Common, say you're using PySpark from your notebook.
Mm-hmm.
you can of course use credentials. And, if you're using something like you can use the Hive connector to interact with data stored in S3, and you can just plug in a static. That's all fine and well. The thing about static credentials though is that they're it's probably not the cleanest thing to do in terms of security, because there's no built-in mechanism to really rotate them. In the case of Kubernetes, neither of the options that you have for credentials are really fantastic, right? You can kind of squirrel them away in a Kubernetes secret, and then you can expose them to the pod by way of an environmental variable or something.
But you still have the management headache, like that doesn't.
It's just they're stat, right? It's like having a, I don't know. So it's kind of not the best, right? So additionally, the mechanism that you get is where you can use tokens. You can do tokens authentication using Amazon's secure token service. And the ways that you can do that is you can take your static credentials and you can interact, use them to sign a request to the secure token service API and say, give me a free token, and then you can kind of get it. The template in the way that works is it's an access key, a secret key, and then like a token ID, and you can use that to sign requests. So if you have an application, you could provide like you spawn a notebook and pass it to the environmental variables. During the spawner, you can add an arbitrary list of environmental variables, and you can that in to your notebook. But that's not really ideal either, because a secret token expire, and you'd still have to sign static credentials. So it's not really ideal for notebooks, but it's perhaps even less adequate. You have something that you want to be running in the background, because I forget what the default expiration time is. It's like 6 or 12 hours. So if the token expires and it's like sort of service, doesn't really have a means to generate a new token on its own SDK. Now, if you're running your application in just EC2, you have you can kind of assign a role using like IAM to the instance, and then if you're running any sort of application inside of the EC2 instance, and you set it to use assume role, what it actually the SDK actually does is it reaches out to a metadata service in EC2 that's like kind of defined IP address. So it'll go, it'll talk to that metadata, and that meta service will like get a sound response, and in that it'll provide a key, and that SDK is actually smart enough to okay, my key is about to expire. I'm gonna interrogate the metadata service, and I'm gonna get a new key, and then it'll use the new key to sign requests going from there. So that's kind of a nice way of going, but it kind of breaks down Kubernetes, right? Because of the way the networking works, your pod often cannot, unless you're doing host networking or something like that, doesn't have the ability to interact with that metadata server. And so if you're running an application on a pod, even if that pod is running on a node that is an EC2 instance that has the ability to role, the pod actually can't talk to that metadata service to get keys.
I see. Okay.
Yeah. So there are some people that were experimenting with there was a tool called Kube IAM, which kind of like a proxy service that would run. It would be like a daemon set that ran on every single host in your cluster, and if a pod to the metadata service, then it basically proxied, or if it tried to talk to the metadata service, it could by proxying through this Kube to IAM theme. And that's kind of neat because then you get the ability to rate your credentials, but all applications that were running on that pod would basically be able to assume the same role. which could be less desirable, right? You wouldn't really want a situation where you had like different sets of nodes that were able to assume roles, and then you only permitted certain namespaces to run these nodes, and then other namespaces to run on these nodes. And like you could get it set up to really make it so that you could have different access control for different like pods that are running for different namespaces. But it's really an obtuse way of doing it, right? You would have to use taints and tolerations, and I don't know, it'd be messy, right?
Okay, so you're saying that to get a real level of granularity down to the pod in that scenario, it's just cumbersome. That sounds like you couldn't.
Yeah, you actually right, because the node has the ability to assume role, not the pod, right? And pod is what the node is really just where a pod could run. What you more ideally want is the ability to have a pod assume a role, right? You can say, and this is the next slide where we talk about, you can say that this role is able to access this stuff, and so you really want to be able to this pod, because it's in its namespaces, is able to access stuff, but these other pods they can't, right? You don't really want to do it at a node granularity. So with the clever folks over Amazon worked up was, well, they already had this mechanism called assume role with WebID, where you could, instead of using your static credentials to generate a temporary token, you could get an attestation from an OpenID, which is cool because OpenShift also supports OpenID providers to authenticate to the Kubernetes API, or if you log into the console, and so kind of have a common identity provider that is working with your access control for Kubernetes itself, and also for access control for your data lake. But it was kind of a similar thing where you would have to, the pod would have to, you would have to, in order to have the pod be able to kind of run in the back as like a service, you needed a little bit more. And so that's where pod ID comes in. So pod identity in Red Hat OpenShift service for on Amazon. It's if you're provisioning cluster with the ROSA CLI, you do ROSA cluster create, and then it kind of prompts you a bunch of things, plus you pass a bunch of flags. It basically walks you through prompts, and one prompts that it'll ask you is whether you want to deploy cluster with STS or security service. And what that actually does is it sets up a pod identity hook, so that when a pod runs, you can basically configure server accounts in different namespaces, and applications can run under the service accounts, and it has some fancy behind the scene that is going to interact with your OpenID provider, and then get a JSON web token, and then project that JSON web token in a pod. And that JSON web token can be used the STS API. So it's kind of like this crazy like chain of crypto stuff. So it's JSON web token and uses it to sign to the STS endpoint. And the STS endpoint issues an STS token that can be used to sign requests with the object store. So it sounds creepy, but from your application's perspective, it's super awesome, because what you do is in your application, you just say run this application under this service account, and then the SDK in the application just does everything for you, right? You don't need to set environmental variables, secrets, and then map those secrets into notebook or Python, variables or anything like that. It's all kind of old transparency.
So do you have a demo of that actually working?
I don't have for today. But potentially
okay, we'll have to do another
guys
show with the actual demo.
Yeah. No, I can certainly do that, and if I don't have it right now. But it is super cool. You'll have to take my word. On the other side of things, right? There's if you and what comes in is if you want to you need to do authentication also, just like in Jupyter Hub, where you have its own authentication, because sometimes, or at least in the case of roads, you have the Jupyter notebook spawner, and you authenticate with the spawner so that you can map an identity to the notebook that's being spawned.
Right.
Similarly, if you deploy a Starburster, you're really going to want users to authenticate with when they're sending queries to the coordinator, which is kind of the dispatches the query in the Trino cluster. Or if you're using like a visual tool to interact with the Trino, like Superset, you can set up a Trino user impersonations. You basically authenticate, like when you log into Superset UI to dispatch queries, it actually does authentication with Trino, and so it kind of like pushes it. It kind of passes through. The coolest thing is that it also Trino also supports OAuth 2, so you can authenticate with it with an OpenID Connect provider. So you can have your access to your data lake, access to the query engine, and you can have your access control that's tied into the Jupyter Hub notebook spawner, and access control of Kubernetes. You can have them all tied back to a common OpenID Connect provider, which is kind of ideal, right? You want to manage different users and different systems that you want to be able to, like, if Tom, Dick, or Harry leaves the organization, or if they have a different role within the organization, you don't want to have to like remove their credential from a bunch of stuff, or like change their, you want to do it centrally in one OpenID Connect provider, and that way you have covered across all different aspects of data processing and data science, utilities. If that makes sense.
Totally, absolutely, cool.
So we move down the line more to actual access control, right? Authentication is saying, like, Michelle is in fact, Michelle, right? Or Kyle is Kyle. And beyond that, you need to have some sort of definition of like what those people are going to do. So part of authentication is also, any sort of roles or attributes that map to that particular principle, right? So when they say principle, what they mean is like a service account is a principle, a person is principle, or and so it's kind of like a more general term, I guess, in access control parlance. But yeah, the same thing. So earlier I was talking about how there's a number of different ways of doing authentication with S3. Similarly, because it's grown organically, it has several different means of access control too. So in the earliest days, it had these just basic ACLs. That was like you can set up a bucket to be public, or a certain prefix to be public. You could set it to be private, or you could like set it to anonymous access, and so there's kind of some course level access control type stuff you could do with like the earliest S3, but then it over the years it started to get more sophisticated, and the next step in the evolution of access control was the introduction of bucket policy, which is pretty powerful because it means that the access control is actually controlled at the point where the data lives, right? So you define the policy with bucket, and so if which is kind of a nice, when people are talking about this new idea of like a data mesh, it's that instead of trying to like have some sort of like centralized control or policy, you define policy with the data, and then that way people that are creating the data usually have the best idea about the limitations that need to be placed on it. Thing like where it originates from, in the case of like if there's country of origin and type stuff for GDPR. I don't know. That's right. Right. The kind of the data protection thing out of Europe that says like, you know, if you have your data has to stay here, and then there's certain rules about being able to, you know, delete stuff. There's similar things that are required for information about people from California. I forget what the legislation is, but yeah, so it's growing. There's this growing. We need to, you know, basically govern data specifically based on the person that the data is about, and all kinds of other things. But the main point is that the people that are creating the data have the best idea of what options should be placed on the data. So having the policy with data is pretty powerful. And bucket policy is pretty rich. So you can have it, and you can say that these roles or these named principles or these named roles are able to access either the entire bucket. They can limit the API operations they're able to make for that bucket, or prefix of buckets, or objects in the bucket with particular labels. So you can say there are cases that nobody has buckets gets us. It has the, you know, like general classification label, and by default objects written in and don't have, and there's something in the background that's looking at the data to make sure it doesn't have any PII or something. And then once that thing verifies that it doesn't have PII, it adds a label to the objects, and then you know all the people organization are able to access that. You can do something like that. IAM policy is kind of the other way, the opposite end perspective, and you usually want it when you also are using other Amazon services, and you need something that like transcend just the data. So kind of add a little bit more capability there, but in a lot of cases you can get away with just using bucket policy in combination with the principles based on the access goal. So if you have pod identity, you're able to do like assume role type stuff, and then you're able to say, you know, these roles are able to access this data by label, by prefix. And if you look at how like most data warehouses are organized, like say you wrote a bunch of data with Hive or something, you know, prefix is powerful because the layout in the object store of data, or you know something like HDFS is it would be like /warehouse/database/ you know name, and then underneath there's often like separate like pseudo subdirectories that have the different partitions for a table. So you know this prefix alone can control who has access to a particular database or particular tables, or even particular partitions within a table. So that's pretty rich, right? That's if you have used object storage before, or a delay type thing, that's what you would get if you configured Hive to do like delete or push off access to HDFS, right? So that's what you know makes it on parity with the HDFS in terms of access control. In fact, it's a little bit richer because you can do contribute based access control, even with with labels, objects, and stuff. So you can do some kind of fancy stuff there. What you can't do though, is you can't do any sort of like column level security, because the granularity is a whole object, right? So you can only say that Michelle can operate, do these particular requests on the object completely, or not at all. And if you're writing data in something like CSV or Parquet or JSON, you can't really control. You can't really say like within the object you only have access to these. And get that if you use something like the Ranger plugin for Trino or Presto, where you could say, okay, Michelle doesn't have access to the whole object, but if she runs a query Trino that only access the columns that she's permitted. If you have Parquet files that represent a table stored in S3, she can't access it directly with S3 or with Spark or something that's not set up Ranger directly, but she can go through Trino that's can go with Ranger. Ranger policy says that she can just access the customer name query, but not the credit number query or credit card number column. And so that if you need minor granularity, if you need like column level granularity for access control, that has to be done some sort of policy enforcement point, like the query engine itself. I have like a visual on that, or an example.
Kyle,
Yes.
sorry, I don't hold your thought. So, so the echo is still present. Someone in the chat just let us know. Do you see a settings bar or anything? Do you think there's anything else you could do on your side? I know I have a settings cog where I can make sure that echo suppression is on.
Oh, let's see. Right.
There isn't actually very much to toggle with, but
I have
stuff. So anything we can try.
Noise control. I don't know if that's Is this any better?
No. And all your kids are sleeping, right? Everybody's no one's making things choppy. So.
Hopefully, unless I've gotten too excited here and turned them up.
All right, okay, so we can continue. Just thought there might be something else.
Yeah, I'm sorry. I don't really know what.
It goes in and out, like right there. That was fine. That was totally fine. No worries. Okay. All right. Sorry, you were saying you held a thought, and
yeah. So I was kind of diving into how you could have more granular access control than just object level, the level if you want to drill down and be able to do access control for just particular columns, or if you wanted to make sure mask particular columns. So if you wanted to mask a card column or a social security number column or something like that, you would have to do that with sort of policy enforcement point, which is kind of could be anything, but oftentimes it's you would do it like a sort of query engine that has some sort of plugin with something that has kind of richer access control semantics that take into account columnar data as opposed to or tabular data as opposed to object data. And the next thing is of course a hot topic. And on the object storage side of things, the SDK is capable of doing client-side encryption and decryption. And you have to manage your own. You have to manage your own encryption keys. In that case, you can also kind of have the storage system do the encryption for you. Right, and that's server-side encryption. And there's three different varieties of keys are managed. You can manage the keys themselves. So whenever you do a request, you say, S3, either encrypt or decrypt the object key. And what S3 does, it takes that that's included in the request, which is why the key is in there. It enforces it, makes mandatory the use of HTTPS. That for obvious reasons. But it'll encrypt decrypt if it's a put request that is doing a object, then it will encrypt the body of the request and store it. If it's a get request, it's a read call. It will take that. It'll pull up the bits storage system and then it'll key to decrypt it and send the decrypted payload to the client over encrypted channel over HTTPS. It's in an encrypted tunnel, but the bits inside of it are not. The other option is if it doesn't want to deal with the keys, they can either have the keys stored in the storage system. That's called SES3. So it's like just S3 stores encryption key. You can also do SCC KMMS, is where instead of the encryption keys being stored in the storage system, it kind of coordinates the storage of the keys with Amazon KMS. so that and Amazon KMS can, it puts the keys in like hardware security modules, basically. So really, really fancy security. But I mean, you're still getting to someone else to have the keys, right? Of course, if you have like a really strict requirements, it's always best if you encrypt something, you're decrypt something yourself, separate from whatever service. But that's kind of the hardest thing about cryptography is key management, right? So you're taking on the most burdensome thing about cryptography by if you do that. Now, again, just like access control, all of the object storage-based encryption and is all whole object clarity. So it means the entire object is encrypted using the same key. So if you wanted to control, just decryption of particular parts of the object, there's the SDPI gives you or it doesn't give you fine granularity to do what you want. Which is where something like Trino can come and Trino, and either no encryption or can use the S3 service encryption, or there's actually encryption that's available in Parquet deserializer, Parquet with modular encryption, which can actually use different encryption keys for different columns, which is just pretty cool. So you can access control to particular columns, but you can also encrypt different columns and keys even. I haven't played with that too much with Trino, but a thing that exists. The data format is knows and is able to do in many of its serializer, deserializer implementations, encryption and of just particular columns. So all of data pages that correspond with a particular column, they'll be encrypted with per column, which is pretty fancy. And then there's some other things. I actually think this is just no mistake here. I had
no
slide. So here we'll fix it live here. So there's also a few other kind of management things that are kind of handy for object storage. Some of them have are security relevant. So there's probably 6 or 7 ago, Netflix did, or for a while it was almost every year. They were like at the Strata conference, they would talk about their best practices with their, because they're all in on S3 as a data warehouse. I think it was like 4 years ago, at Strata, they said like 60 petabytes or something in Amazon S3, something insanely huge. I'm sure they're probably 150 petabytes or something now. It's not making that up. I'm just guessing, right? It had 60 4 years ago or 5 years ago. They probably got at least double that. So they use versioning, and versioning is a good kind of like protect people from shooting their self in the foot kind of thing. Because if you have object versioning, it's like the like a super snapshot, right? So if you have any sort of store background, there's this idea of like taking a snapshot of things, and if it's a file system, you like take a snapshot and say, oh well, every hour I want to take a snapshot, and then if something that happens, I can go back with the this hour snapshot or whatever. Well, versioning is actually way better than that, because it keeps a version of every change to every object, unless you tell it to start old version. So it's not time based at all. It's based on modification. So you can if you write key ABC bucket foo, then you write another. You write to that key in there's a history of all the different versions of that object, unless you delete ones, some of them. You can make that even great for if a developer is writing into a bucket and they accidentally clear data, right? Stuff happens, right? Certainly make mistakes. We'll probably make mistakes in the future, and putting things like these helps kind of prevent me from shooting myself in the foot, and the same for others. Now you can delete older versions of objects. So if you actually really got yourself in the foot and like deleted all the versions of an object and you didn't mean anything, that would be bad. And you wouldn't have any recourse. But you are able to also do something called MFA, or multi-factor delete configuration on a bug that's been configured for our version. So if you configure versioning, you can set up that multi-factor delete, and then in order to delete versions of objects, you have to use like a multi-factor or authentication with a request, kind of like, if you shoot yourself in the foot way of also signing requests and like going through the whole dance with the Google Authenticator or something like it, then all right, well, your own, I guess. But you have kind of it's kind of like this defense in depth. You have the versioning, and then you make it so you can't delete the versioning without multi-factor authentication. That's pretty good. It's pretty safe. Other useful things are like expiration and transition. So if you have some data that needs to expire after 30 days or something, instead of having to go back and keep track of how old stuff is, this thing can do it for you and say, okay, after 3 days, after 60 days, I want you to delete this data. It's actually really handy for things like Hive, like some stuff with like temporary table. So and the prefix for keys for like temporary tables look a certain way. So you can say, anything that looks like it's a Hive temporary table or week or something, it's probably just orphaned, right? And instead of having to like go back and remember to clean up that stuff, you can purge from the system after 7 days, 14 days, whatever. But you can also any sort of data that's going to go stale, and you really want to delete it anyways after 30 days, or you need to delete it after a time period for some sort of regular purpose. You can configure your storage system by way of some sort of life cycle policy to automatically delete the data after a certain time. Also do addition, which will store in different storage class or something called older. Object lock is to be able to do worm type functionality. So if you have to comply with like FINRA regulations because you're bank and need to be able to write data and like seal it, and then not be able to tamper with it for a specified period of time. And oftentimes for I don't know if it's a FINRA thing, but I know most worm implementations also have this idea of like a litigation hold, where you can kind of put a hold on. When you set the object lock, you basically like this object can't be put with for this period of time, right? So 30 days or a year or 5 years or whatever. But in some cases, you want to stop that timer because there's some sort of suit or something, right? There's some sort of litigation, and instead of this like idea of like a litigation hold. So you might want to say like pause the timer, right? So that's a thing too. And then finally, there's the object tags. Referred to this earlier, but object tags are really powerful when combined with access control, because instead of doing access control based on a bucket or based on a fix within a bucket, you can buy tag. So if you have things dumping data into like your data lake or whatever, you can have some sort of automated process. And we've done some cool those before where you like set up a bucket with notifications, and then that triggers like some serverless stuff in native, and then for each object it like does sort of inference against it to see if it's I think we did like an X-ray one, right? So it looked at and did like a pneumonia score for the X image. But you could also do something like if it was tabular, you could have it look, and you could have it do inference against the table and say, oh, this does or doesn't contain PI. And then the result is they could add a clean tag or something that allows more people to access the data. And if it does have PII, then it can put a label on it that says like sensitive or something, so that you can use that to control access to data too. So I did give kind of a more an example type thing of how you can kind of coarse and finer, like kind of like hybrid Trino and storage-based access control for a data lake or a data warehouse. It's kind of all these cups. It gets kind of tricky. So I thought like a good diagram or an example might be good. So let's say we're going to do like a classification level like the government uses, right? Where it's like tiered access control type thing with public, confidential, secret, top secret. And then you create corresponding roles for principals that are able to be access public, confidential, secret, or top secret. And there's a whole bunch of like rules to kind of make it work. So if you have roles that can only write to buckets of equivalent security level, so if you have like a top bucket, like only people top secret get to a top secret bucket. If you have or certainly doing these sort of change like the tag or something, right? Because that could adjust the access control. Roles at the higher security level read from the lower security level. Rows and columns can have lower security levels than the bucket stored in. So you could have you could actually have like some of the columns in like top secret bucket might just be general access. Rows and columns cannot have higher secret labels than the bucket because they could access the whole object. And, that would compromise the security. The roles can't directly access buckets or objects with higher security, even if they have lower security rows or columns. And then the policy enforcement points, right? So I talked about this before. They're able to assume the roles, and they can like basically filter data for the lower security roles, and then only give them the data. Right, so they're able to dip into a secret bucket and then filter out the data that is secret, and then can give like say just the general columns, the general access controlled columns to a general access control user, right? So you need a policy enforcement point if you need to like sift through the data, finer granularity. And these policy enforcement points should only be administered by users who can assume the role of the policy enforcement point. Policy enforcement point has the high privileges. And so what it kind of like is this, right? So if you have, say you have your roads notebook namespace that your notebook is running in set up with a particular service account. So say you put an annotation on the namespace or something so that all of the pods that were running in the namespace would run under a certain service account, and you provision the cluster also with STS, so that this service account that you defined in namespace would be able to kind of do the whole dance around, using STS controls to sign requests, and it's all tied back to the OIDC provider. Then you have a Trino namespace, and either the Trino namespace or the Trino pods within the namespace are configured with a separate account, right? So in this case, it would be what do I have? The confidential, right? So anyone, like any of the notebooks that are running in the notebook namespace, they're kind of general access control. But if you need access to higher security levels, right, you could have a Trino namespace, and so you could have a Trino namespace that would be the highest level, and it would just filter out the orange or the yellow or the red for users that have orange, yellow, or red security level. Or you could have kind of like different, if you wanted to have it be like this cluster is like in this case, we have the confident, Trino namespace. And so the service account for the Trino that's running in that namespace is limited confidential. So it can't do secret top secret, but it can filter out confidential information from general information and then give it to a general user. So the Trino service account would need to be to the highest privilege that it's capable of accessing. And so if you look on the data side, if you have whole objects, right? So if all of the calls in the object and then in the bucket are all kind of general access, the user just access it directly. Like they go in their notebook, they use Bodo, they can use Pi Arrow or something like that to like have the data out of Parquet, and then they can manipulate it, and then they can just do that directly with the storage system. if they need to access green, and they're permitted to access green data, but that green data is kind of like mixed in with other columns that are confidential, and so it's in a confidential bucket as well. Then you need something like Trino to be able to do more granular access control for you. So this is assuming, and in order to do this, where it kind of sifts out, masks off the credential data. That's where the tie-in integration with Apache Ranger comes in, because that's where you define the more sophisticated policy. If you're just doing like storage-based policy, then you're in the same situation at the bottom with Trino, right? So if you want the more sophisticated access control, you need to use something like where you can define per column policy. But if you do, then you can filter or mask out the confidential columns, and then just provide the general access control data to the user. And so now you kind of have this really nice system of access control, where users and different tools are able to access the data directly if they're able to interact with the whole object, but they need to act more granularly on just specific columns, then they're able to do so by way of a policy enforcement point.
So one question. So just to sorry, I may have missed this part, but so Ranger, the role of Ranger is to allow you to set this level of granularity, this level of policy, or to morph the end results like altogether, or both?
No, Ranger is just the policy, right? So
just policy. Okay.
Yeah. So Trino talks to Ranger, and it says okay. these principles to access columns, and then it can deny or enforce filtering or masking of particular columns. Okay. But Trino itself is the one that actually does filtering or masking. So when I say masking, usually what it does is it like takes all the values for a column and it hashes them so that it's just garbled, right? Okay. Instead of bringing the actual instead of filtering out the it's kind of like anonymization almost. Anonymization is because it tends to not anonymize all in a lot of cases. I'm not going to get into whether Trino or not. I don't actually know if it's good, but it can mask. And so that's like you want to return the column that has like the credit card number, and you want to be able to like have the cardinality. So that you can see like the number of unique credit card numbers or something, or the number of credit cards per customer or something, but you don't want them to be able to actually see what the credit cards are.
Right.
That's when you would use masks to the filtering.
Okay. Okay.
But yeah, or addresses or anything like that, right? If you still needed to know like have them have some sort of unique values, you count them or whatever. That's where you use masking filtering.
Okay.
But yeah, the masking or the filtering is actually done by Trino. The Ranger is just like where the more granular rules are stored.
Okay, thanks.
So that's kind of my crash course on data lake security stuff. If there's any sorts of questions,
I do think we'll have to, because of some of the issues with audio, we may end up like recording parts of this, because it's chock full of good information, and we can talk about if we want to do some deep dives on particular things. But that was great. Like I wasn't sure what we were going to talk about today. I know you gave me a little blur, but I was like, well, okay, I'm not sure. But this was like a really nice overview, and I thought I would like to see, maybe we can do a future demo where we actually, even if not the whole thing, but just like a little part of it, like
do some stuff through,
do
some stuff in notebooks, like using like the static credentials, and then using the new STS mechanics and ROSA, and then kind of from there we could play with labels or something. I don't know.
And there's definitely a
it's
set of
something with
questions, like
Granular.
things that that someone who's going to go set up security for their data lake should be thinking about, right? What's the level of granularity you need? It's going to be on column data. Are you going to need extra policies set in, like all kinds of like just like a guide, like how do you actually approach this stuff when you're doing it at the data lake, and don't assume that what you get out of what you know from S3 with bucket policies and IAM and all the stuff is going to be sufficient. You may have to think about some other things. So that was really cool. Awesome. Well, so we're kind of at the top of the hour. I will put out, if we decide to re-record and so that we can get better audio, I'll definitely publish something and tweet it out saying when it's available, and maybe we can even replace this one. I'm not sure how we do that exactly, but we'll see. Anyway, I don't see any questions at the moment, but I want to thank you, Kyle, for getting up early and putting this together for us. and I'll let you, I think we will re-record. I think that's a good idea, just to make sure the audio is a little clearer, and we'll publish that as well. So that'll be really awesome. Cool. Well, thank you, everybody. So I just wanted to say, have a good day, and I'll talk to all of you later. Thanks so much. Thank you, Kyle. Thanks. Talk to you soon. Bye.